Let's do the next question, which is question number 3. The hardness of a groundwater sample was found to be 420 milligram per liter SCaCO3. A softener containing ion exchange resin was installed to reduce the total hardness to 75 milligram per liter SCaCO3 before supplying to 4 households. Each household gets treated water at a rate of 540 liter per day. If the efficiency of softener is 100%, the bypass flow rate expressed in liter per day is. See, the question is about that there is a source. From source, the groundwater sample or source, we can say it is having 420 milligram per liter hardness. We want to supply water, and the supply should be final at 75 milligram per liter of water. From source to supply, in between that we need to reduce the hardness from 450 to 75 milligram per liter. Okay, for that they are using a softener containing ion exchange resin was installed to reduce the total hardness to 75 milligram per liter. So there, let's suppose it is the softener. They are putting the softener in the water, and after the softener, see, softener will do what is the work of ion exchange softener. It will reduce the hardness to 0, from 420 to 0. Hardness will be reduced this much, but we need 75 milligram per liter. So for that we need to just bypass some water to the tank directly without treating, and we need to mix this softener water and this bypass. So how much bypass should go so that the end result from softener the hardness is 0, from bypass that means the total 420 milligram per liter water hardness is coming to that, and it should become after that 75 milligram per liter. So this is the question, and we need to calculate how much water of the bypass, how much flow rate we can say. If we know the volume, we can know the flow rate also, discharge also, right? So first of all, they are saying that each household gets treated water of 540 liter per day, and there are 4 households, right? So the total clean water we need, that is total water to be treated is 540 into 4, that is 2160 liter per day, right? And resultant hardness required is 75 milligram per liter. Let the bypass rate is x. Okay, so the hardness of mix is nothing but the hardness of, we can say, hardness into discharge of total, we can say mixed discharge, like final discharge mix is the hardness into discharge of, we can say, softener plus discharge of bypass into hardness of bypass, right? Okay, now the mix has hardness 75. Let's say the discharge of mix, we are putting it into divide, that was x. Discharge of softener, let's say the, Yeah, we have seen that bypass rate is x, so the bypass rate is x here. So the softener rate will be 2160 minus the bypass rate. Okay, now we got the discharge here of the softener. 2160 minus bypass rate into hardness of the softener is 0 plus discharge x into hardness is 420. So yeah, and the total discharge of the mix is discharge of the mix is 2160, right? Discharge of the mix, because this much will be here 2160, right? So from this we can calculate the value of x. So the value of x comes out to be 2160 into 75 divided by 420. So that is 385.7 liter per day. So the answer is 385.7. So the fourth question is, the potable water is prepared from turbid surface water by adopting the following treatment sequence. So we need to know what should be the sequence of treatment for the water. So for that, the whole treatment, the correct sequence of the treatment of any turbid surface water, follows as: first we do coagulation, then it is followed by flocculation, then it is followed by sedimentation, after that filtration. After sedimentation, water is filtered, and then disinfection, then storage of the water and supply. So this is any typical the treatment sequence of turbid surface water. Now, so, and if we talk about all of the processes in brief, that is, coagulation is nothing but neutralization of charged particles in the turbid water which would otherwise repel each other. See, turbid water means water will be turbid. That means the transparency of water will be less. So in turbid water we add some coagulating agent like alum. What does it do? It creates the neutralization in charge. It creates neutralization of charged particles. Water is turbid because of the negatively charged particles, and when coagulation is added, so all the charged particles are neutralized, and then flocculation starts after that. In flocculation, in this, small individual particles come together to form large particles. Coagulation is nothing but neutralization of charged particles, and flocculation is all the small individual particles come together and make a flock, bigger flock, right? So the larger or bigger flock settles down easily. So after flocculation, the particles, see, turbid water is the water in which Some particles will settle down at bottom, but some will never settle down. That only is creating turbidity. So for those particles we add coagulation, that means alum. We can simply say we add alum, and after that, after adding coagulation, the charged particles come together, they get neutralized, and flocculation is the process in which all neutral particles come together, and then they start settling down. So the turbid water, the turbidity elements are now settling down at the bottom. When they settle down, then process of sedimentation happens. Sedimentation is done so that the large flocks which are formed in the flocculation settle down. And then finally filtration is done to remove very small particles. See, sedimentation works for larger particles, and when we have very small particles, that is removed by filtration. Now disinfection is very much needed for all waters, and then storage and then supply. So this is the process. So the correct option is matching: turbid surface water, coagulation, flocculation, sedimentation, filtration, disinfection, storage and supply. This is the first option is the correct one. Now if we see question number 5, a water treatment plant is designed to treat 1 meter cube per second of raw water. It has 14 sand filters. Surface area of each sand filter is 50 meter square. What is the loading rate in meter cube per day per meter square with 2 filters out of service for routine backwashing? So see, for this question we have given the discharge of the water treatment plant, that is 1 meter cube per second. If we change it to meter cube per day, or we can say if we change it to meter cube per day, that is 1 meter cube 1 second. If we change it into day, that is in minute 60 second, in hour 60 minute, and in a day 24 hours. So it becomes at meter cube per day. Now this comes as 86400 meter cube per day. In a second 1 meter cube discharge is coming, and in a day that becomes 8640 meter cube per day. Now we know that what is surface overflow rate. We read just now. Surface overflow rate is nothing but discharge upon surface area, which was nothing but B into L. Surface area B into L. So the surface overflow rate, it becomes, if we see, surface overflow rate is nothing but discharge upon surface area, and discharge is meter cube per day, and surface area is in meter square. So we can say meter cube per day per meter square. So what is the loading rate in meter cube per day per meter square? This is nothing but they are asking about surface overflow rate, right? Now what is this surface area? This surface area is for filters, right? On filters only the discharge will come on, and the number of filters, sand filters, is given as 14, out of which 2 filters will become out of service for backwashing. So the filter number that is used, number of filters, that is 14 minus 2. At any time it is usually 12 filters, right? Okay, and for each filter, what is the area? Area of each filter is given as 50 meter square, right? 50 meter square. Okay, then if we want to calculate surface overflow rate, that is nothing but, okay, we have 50 meter square. First of all, 50 meter square is the area of single filter, right? Area of single filter. And for 12 filters, the total area becomes 50 into 12, that is nothing but 600 meter square area we have for this much discharge. So what will be the surface overflow rate or the loading rate, that is discharge, that is 86400 divided by 600 meter cube per day per meter square. So it comes as 144 meter cube per day per meter square. So the answer we can write here is 144.